I kind of picked up a potato. I don't know how in the planning meetings. It said I was talking about open data and closed data, and I went, "Oh, I can do that. I've read an amazing book." And I've had a few challenges in this, so I'm going to try and give a different perspective on open data and closed data, and the perspective of the research community, and how that really applies to what we're trying to do in the Ecological world, and bringing time series together, and in sharing data, some of the challenges. As I kind of put this together, because I've had a few conversations on this, I've kind of had some very different conversations with many researchers on this topic. So I figured to start this talk with a bit of a trigger warning. It's a challenging topic. It really strays into long-held research cultures across the research community in the way they work, in the way they do science, in the way they publish. And within this talk, I'm looking at kind of how we perceive things, some of those policy drivers, where things are going, and how that kind of affects the community and where we get that kind of conflict. So we can actually understand why we're seeing these challenges, how people kind of feel about it, and then kind of look at how we go forward. It's not about dictating open data, it's about looking at people's perceptions, their feelings, and why we get that challenge around open versus closed. Because yes, so please, there's nothing in here that's dictating, but it's around exploring those challenges. And when I kind of agreed to take this on, I was also thinking about where I'm going to come from here. So 2 decades ago, I was doing a PhD in Manchester. This is a picture of the rotating turntable in Bermuda in France. And we were collecting data that there was no for it. Data management didn't exist. There were no repositories, there were no approaches, there's no data management training. I was blind as a PhD student, and I don't think there are repositories for this data to this day. So there's a lot of data out there that doesn't have the means to actually do the data management. And then I ended up at BOC, and I was in the midst of my time in the Argo program that decade. And Argo is a very open culture in terms of data. It's there by design. And it really taught me a lot about open data and how to work, and also data management, because they designed it at the beginning. And then November year before last, I got the job I always wanted from the PhD. I'm actually creating new robots, trying to do things with robots in the ocean that I was trying to get data, and I was got before research problems. We hadn't much to tackle that. But that then I got exposed to lots of different research communities, and I'm getting exposed to lots of new communities. And they all treat data in a different way, they all work in a different way. And some of those kind of challenges around open versus closed are really coming to the fore within that job. So maybe I'm the right person for this job, because I'm still learning. And part of the driver for this talk is the policy drivers. So I picked 2. There's dozens of policies around the world I can pick up that drive and pushing towards open data. I've got the IOC policy from 2023, one that I helped write. And it's just this bit at the bottom that's kind of underlined. Data and products should be accessible, disruptable, and openly shared with minimum delay, minimum restrictions. They're pushing open data. And this is the NSF policy, 2013. I think this comes out of Obama originally. Correct me if I'm wrong. Effectively, a plan to support increased public access to the results of federally funded research. And this includes the digital data resulting from Russian research. So the policies are pushing towards open data. But there's many, many barriers to this. And I've just picked some highlights, and there are a few more identified in the survey that you saw yesterday. And the big one is trust. So when you share your data, you need to be comfortable that people are going to use it in the right way. You're going to get credit for that work. The data are not taken out of context. And that's skipping one. It's a real perception. All of these perceptions people have are real perceptions. Like that. And within trust, there's a huge kind of an elephant corner room, and that's AI. You look at ChatGPT has swallowed up all everything you find on the internet. It's using it to give good results. It's not crediting anyone for what's actually going on. So that's actually a real issue we're facing at the moment. Infrastructure, already covered that. So for new data types, image data, video data, a lot of the repositories and practices we need to actually manage that data and actually share that data don't exist yet, which makes it hard. So if someone wants to share the data for the new data as they come along, we're still building systems for only extension, for example. It's actually very hard to actually share that data. Resource. It takes time, money, effort, human beings to actually get that data to a point which is really useful, it's curated, and it's actually out there and formed and used, and actually used in a way that you're sure will be right. And there's a real kind of debate about how do we balance that with research. There's only so much money for research, and the more curation we do, that can reduce the amount of money available for research. And the last one I've got here, I know there are more raised yesterday, but the carrot is missing. We have, I'm going to show you in a bit, the ability to actually look at citations, but we don't have the right kind of motivation, right carrot in terms of the value to people when they actually open and share their data up. The incentives aren't quite working. But so yeah, the challenges, but I wanted to go back to my Argo days and learn about open data. And it really is kind of like a huge kind of beacon in terms of open data sharing. When Argo was envisaged in 1998, in order to make Argo work, there's going to have to be open. You're putting these profiling folks in water. They're going to go across international EZs, straight into people's territories all the time. And that means that they have to be open at that point of collection. It gives the program transparency. It's used very heavily in IPCC. If those don't use IPCC, people have got to be able to access them, use them, and to trust that source. Trust that source. It's the biggest source of subsurface salinity, increasingly the largely chemical data with the BGC algorithm for BGC. But this has led to this huge impact. So there's actually a guy called Fred in France, and he puts a lot of work into tracking those citations of the Argo data to actually get an idea of their impact. And this graph when I was travelling, and it's nearly 7,000 papers since 1998 cited or used Argo data in some form. And this has been, a human being has been through this and actually vetted all of these to make sure they're all relevant applications. And this is the true measure. This wasn't done automatically. And I'm going to come to that kind of scooping, people getting a scoop on you type thing here. So this is Remick, one of the fathers of Argo. And he has published at least twice a year on the Argo dataset since its inception. So he is still getting the publications. This is one of the Nature publications based on that, because he, as one of the lead researchers, understands the program, understands the data, understands what it's for, gives him that advantage in publishing from it because he knows it. And this paper here is particularly pertinent. What we're talking about, 135 years of global warming. It starts from the Challenger position. It looks at all of the temperature salinity data, 135 years. So it's from Argo, it's from ships, it's from Challenger, it's everything they could get. And then to aggregate that into a time series in order to actually get a meaningful measure of ocean warming over that period. So yeah, it's one of those examples of showing open data working. And it covers some of those concerns. And then, but not all data should be open. So in the work I do now, the work at the BGC, I've encountered data that are closed for real reasons and genuine reasons. People's national security, passive acoustic data that the military collect, for example. But even that, so I was at home during COVID, I was about 3 months ago, things were getting pretty bleak at that point in time. And I got a phone call from the Royal Navy. And they turned around and said, we have a data set you might want. Because during COVID, shipping stopped, the oceans went quiet. And they had effectively a baseline data set of quiet ocean with just the marine mammals. And they were willing to share it with the research community. And they did, and I got the right people. They needed that data, so they could do the science on it. So even data which has got kind of national security around it, in the right context, in the commercial confidence. I've worked on sensor development project, platform development projects. Those data initially are closed until that product comes live, and then they get opened up to the community so they can actually do that review of them. Protected species, BGC hold data that actually contains endangered or restricted species. The metadata around positions and times are actually obfuscated, so the outside world can't see it in order to prevent poaching in trophy hunters. And then also there's that capability which I've kind of covered. There are data types and where technology doesn't exist to actually kind of open that data up yet. And that we need to do work with humans to address that. So that was where I probably stopped the presentation prior to starting a new job and prior to having all those different conversations. And then I kind of worked with a researcher called Gender Project. And she was really struggling with my perception, and I was really struggling with her perception. And she turned and said, read this book, please. So I went and got the book. It's about 800 pages long. And it very beautifully and eloquently describes all of those challenges that the research community have with making data accessible and making data open, and how that clashes with what they were taught in kind of research data culture. It's got many problems presented, very few solutions. I'm going to kind of give you a few kind of highlights from that book that I felt quite pertinent, and then where we kind of sit in the community and what some of those solutions are around that. Don't really feel comfortable. So these are some numbers from the book, which are quite nice. It covers the whole academic domain. It goes from science across humanities and medical research. And these are some key numbers. So she actually did surveys across the whole of academia, various use cases, in order to understand data accessibility, data sharing, and capability to manage data across the community. And there's some quite startling numbers that she found. So 1% of people with data accessible after results being published. Transparency of those papers is very limited. 6% of researchers submit the data to community repository, and 88.7% actually store up university institutional servers. And this means that most data in the academic realm are actually out of reach unless people make up those papers. 9% of high impact papers have a full underpinning data online. 90% of academic high impact papers do not. When open data policies by the journals, about 59% adherence. So about 2/3 of people are actually meeting the policies of papers are actually checked. So there's a lot of work to do out there to actually get that transparency in the papers and get the data underneath and opened up. And these figures from 2020. So they're 5 years out of date. I think they're still relevant today. And the book actually goes with use cases, and there are two which are relevant to us. There's astronomy. I think astronomy, because it maps very closely to satellite data we use, and all the satellite observation data we get from satellites is very similar field of those big data. And sensor network science, she actually specifically looks at terrestrial sensor networks. It's very close to goose type data, the station type data that we're actually talking about here in terms of its relevance to us. So that even though they're not oceanographic use cases, they're actually very closely aligned with. So I've got a few slides with some of those kind of highlights from the book. It's very texty, I'm sorry. But I think it's important to kind of see kind of differences in the perceptions from the community as a whole versus kind of what we're talking about here. And the first one we kind of touched on yesterday, data, this is the definition of data in terms of what's taught in academia and what people learn through university. Data refers to entities used as evidence of phenomena for the purposes of research or scholarship. This is keeping the evidence here. And then this is co-data. Complications are the stars and the planets of the entire universe, data of the dark matter, influential but largely unobserved in the mapping process. You compare this to the IOC definition. This is from the data policy that I helped draft. Data is a set of values, symbols, or signs recorded in any type of medium that represent one or more properties of an entity. How will make it different to the definition of use in academia? So when I go to research and say, can we have your data, please? They're not going to know necessarily what I mean because I'm not necessarily talking the same language as well. And this means there's different understanding that leads to actually potential or conflict in terms of when we're talking about the data, when the data comes into existence. The other element is when those data come into existence. Particularly in the biological community, the data comes into existence once it's evidence for something, once it actually goes into that paper. And that's the point of being a raw observations measurements. Raw observations and measurements is not actually what they constitute data or evidence. So that data actually comes into existence being data at different points with different communities. When I'm asking for the data with one community, I'm asking for a different thing, and I talk to another community as well. So this cultural difference, as Pierre Luigi pointed out yesterday, is something we've got to work through. It's something when we talk to people about data, we've got to be clear about data and what they understand about data as well. Because whilst the difference exists, we're going to get that on.
A short interjection. So I wrote that definition for IOC, but also coming from a research background, it's very deliberately written that way in order to show that when you're talking about data, any kind of semiotics that's from a systematic way of representing something is data. It's very important because, again, in the scientific community, we operate with good faith that people want to talk about facts. So you have words like evidence or phenomena, scholarship. Those are all ideals and values we have in science. But as we've seen, you can have data that's very misleading, false data, data that can manipulate people. That's all data too, right? And that's also going to be in our scientific realm soon. So we have to sort of broaden that and neutralize it. And then we can put values on top of it. So good scientific data is more aligned to that, but data itself is more neutral.
Yeah, going to clarify, but the point I'm trying to make here is that people have different understandings, and we just need to respect those understandings about them. And I think that's the key message I'm trying to get across. So I've got one on how to help research is one of the other key things I've kind of read. And most people want to share their data, and it's the fundamental problem is better management of their own data. They need tools to service systems and archive their data in ways that they can reuse them, increases likely their data will be useful to others later. So there's a big gap in capability in terms of researchers and looking after their data and how that data is managed. And I think in neurosciences, we're in a really good, strong position here. Got NSF, our funders, NERC and NSF, actually, they buy into this, and there's real recognition. This is important from the academia, NERC funds the ABC. When most people bid research grants in the UK, that data management is actually top sliced out, so they don't have to worry about that. It's actually and the data center gets core money to actually look after that. We have the skills, we have the people, we have generations of data managers and informatics professionals now that can help this. AGU and EGU informatics, incredible communities that actually are really keen to help solve these problems and develop these tools and actually work with the community. That's our job. And we're also working actively on new data types. We're working on the passive acoustics, working on image data, we're working on those really difficult, challenging data types where we need to build tools to help the research community. So, yes, this is flagged by the community, but I think in our sciences, we're doing the job we can with the resources we've got. We're doing quite a good job with that. There are gaps, but the recognition is there, and it doesn't exist. And then the carrots. And I think we're going to be talking a bit about carrots tomorrow as well, about citation tomorrow. The first comment here is around the amount of work that goes for on behind the scenes, and it's invisible to those that do it. But at the moment, in terms of carrots, we can look at citations. It takes human beings to vet those citations if meaningful graphs like Arco graph. But the information is out there, and we can pull it through to actually see how those data are used with resources that people to do it. There's a work going on in the background to improve this and actually make it possible to do these things automatically. At the human level, we can do this if we put the effort in. But that count of citations isn't enough. So this is these metrics we have in terms of citations. It looks like, and it appears that funding agencies, policymakers are actually taking those and taking them out of context at the moment. And we need to measure. So we need effectively a measure that includes the citations, includes things like fairness, includes where those data are being used. And it's such an issue that NIH in the US have got $500,000 per person, group, or entity that can actually propose a solution to this problem. And that's huge. And I think if we get that right, we can actually get that kind of carrot people need, and that kind of the value that people need to get when they actually make their data and share their data. So then I found, and I started talking about my job at the beginning of what I'm doing, so I'm going to come back to that story and what I've kind of learned in this, because I've been kind of trying to figure this out for about a year now. And I think it's empathy. A lot of these cultures, different opinion, different definitions, they're deeply held. And it's the core of how people do science. So you need to respect that and work with people, taking time to understand those differences, having those constructive conversations, and then supporting the PIs as these cultures evolve and as policies become more important. You need to continue working with researchers. You need to get those tools, make that sharing, that's our sharing workshop. That's very much part of this process. Connect communities and exchange skills. So why we're here. And actively collaborate and develop tools. So coming out of this workshop, actually taking these forward and actually work with the community to keep us going. And a lot of this also comes down to planning. I'm going to mention data management planning in a minute. It's I've got in trouble for those already, and I need one project into new job. But we need to actually understand the community needs. And then while we're planning projects, we need to actually consider what's needed and make sure those expectations are set at the beginning. They don't change in projects. That's when you get those conflicts happen. Yeah, avoiding those surprises. If something changes in the base management plan, it shouldn't be big, it shouldn't be late in the project. We should know this and stuff. That means research, there's trust on both sides of the equation. And I want to finish with kind of more quite positive slide. We work with global problems. We need to be able to share our data. We want to build products, solve the rules we're doing. Global science needs to collaborate and work globally effectively. Those policies rules was open. That means we need to support the community as we train more communities in what we're doing. They potentially work in different ways, have different perceptions, different cultures, and we need to actually help work with them on that. And we need to understand that effective data sharing and that fair data is effectively a precursor to basically without that, you can't actually share effectively within communities. And I think we're in a really strong position, but that doesn't mean there isn't work to do, and we need to keep working this together as a community and as we train. Now I'm kind of finished on this slide, and this is kind of like one of those difficult conversations you have with people as you kind of work through these challenges in the strangest places.